Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Alrighty, so hello and welcome to this week's weekly discussion for the Great Lakes Tech Leaders. Where we talk about all things DevOps and tech related. So let's go ahead and get things started. We should probably kick it off with a couple introductions. I'm Jason Brown, and I've been with Right Brain Networks for about 8 years now. I'm a cloud solutions architect. I have a background in software engineering and app development, and working at a smaller company. You definitely put on a lot of different hats, and so I ended up dabbling in more of like work that would normally be like a cloud solutions engineer, what somebody like that would do. And so I kind of had one foot in both worlds for quite a long time, and that naturally kind of grew into that architect role. But yeah, so that's what I do. And with me, I've got Phil as well. Phil, did you want to give a quick introduction?
Sure. Hi, my name is Philip Wortinger. I'm a cloud solutions engineer here with Right Brain Networks for almost a year, coming up here in a couple of months. My background primarily was in Linux, server, web hosting, and Cisco networking, and just constantly trying to use new technologies, seeing where the tech world's going, eventually brought me to cloud computing. And RBN's where I find myself now. I'm just looking to continue to move forward with cloud tools and what's available.
All right, excellent. Thank you, Phil. So before actually getting into the topic for this week, I also wanted to mention that coming up next month is DevOps Days Detroit 2022. So that's going to be the 26th and 25th and 26th of August. So last Thursday and Friday in August. And it's a really great event where you have a lot of people from the area, a lot of great speakers that give presentations, as well as just a lot of good discussions, kind of similar to the ones that we have every week. So I definitely encourage you to look into it and to register and join up. It's got great presentations, great people, and just great discussions. So it's a great time. So yeah, you can find out more about it, devopsdays.org. You can see right on the homepage, Detroit's right up there. So cool. All right. So for this week's discussion, we have CDK for infrastructure as code. So I'll just start it off by talking a little bit about what the CDK is, and then after giving a brief summary on it, we can go into what our general impressions are. So the CDK is, or Cloud Development Kit, is a development framework that AWS released within the past few years that aids in managing your infrastructure using several different programming languages. So if you're familiar with CloudFormation, this is like the next step for infrastructure as code, and just infrastructure management in general. It's very similar in that you're utilizing programming languages to spin up your resources, but unlike CloudFormation, which is just raw JSON and YAML, you actually have access to a lot of other programming languages like Python, .NET, Java, TypeScript, or just JavaScript. Once you it functions kind of like an SDK. So you just install the modules that you need, the packages that you need, and then you can just use the framework. And in addition to that, There's also a CLI tool that allows you to take your generated templates and upload them to, it helps you to upload them to S3, and then manage your deployments through the CLI, which is really, really nice. So I think that that's pretty much like the top level overview. Did I leave anything out, Phil, in terms of like a general summary?
No, I'd say that covers it all. I don't think I would add or take away from that.
Cool. Alrighty. So yeah, I guess then we can just talk about like general impressions. So um, what are your thoughts, Phil, just generally on the CDK? Do you like it? Do you not like it?
I like CDK a lot. Primarily coming from like a Python background, it was fairly well integrated with my first use of it. There's a lot of documentation out there, a lot of examples, and by having the capabilities of Python behind it as well, it gave a lot of control and customizability to it. If anything, I think the one hangup I might have in that regard is just differences in documentation between V1 and V2 that aren't always obvious.
Right. Yes. That's a really good point. In that just recently they had released the V2 of the CDK, and they put V1 in maintenance, I think just within the past like month or two. And because it's always changing, there's always you got to keep up to date with the documentation, which sometimes it's usually pretty good about being up to date, but yeah, there's can sometimes be some gaps. But yeah, I mean, my general impressions, I really love it. I mean, you're probably going to hear us gush about it for the next 25 minutes, but it does have some flaws and some drawbacks too. So I'd like to cover those as well. But yeah, just from my perspective, having that dev background, you can really leverage the power of object-oriented programming languages, which I really, really like. And it makes things a lot more simpler and less time consuming when coming up with your templates, and usually with debugging. But just as a comparison, at RBN, we used raw CloudFormation for quite a long time. And we developed our own companion tool called Deployer, which it's open source now. If anybody wanted to go to the Right Brain Network's GitHub and play around with it, if you prefer to use raw CloudFormation, that's a tool that you can run written in Python that will sync up your templates and then launch your CloudFormation stacks from those templates. But with CDK, it has that built in, that CLI tool, and what you're writing is so much more brief and terse. Like, I remember we had, using CloudFormation over the years, you'd have a well-architected VPC, with your public and private subnets, sometimes your data subnets spread out over multiple availability zones. And we would refine our CloudFormation templates, as time would go on. We'd make it better and more modular, but it ended up being like something like 3,000 lines of JSON or YAML, which is just crazy. And a well-architected VPC by comparison with the CDK, just writing it in Python, for example, I mean, it's like 20 lines long, which is,
Yeah,
it's awesome.
it's great because CDK handles a lot of the overhead for you. I don't have a lot of defined work with CloudFormation, but what little I've done, I remember having to define and write out every little aspect of it. Whereas with CDK, you import your module, you provided a couple of the required things, and then it handles everything else for you under the hood.
Right. Yeah. And getting off the ground is really easy too in that regard, because once you have that CDK CLI tool installed, you just do CDK init app and then choose your language, and it'll just assemble your directory structure, do all the scaffolding for you, set up all the boilerplate. So you have your main app entry point, and then like a sample CloudFormation stack that's already written. And then you can just add resources to it and add more stacks to that as well. Just to give a little bit more detail about that, like everything within the framework that you use is considered a construct. So if you're familiar with classes and object-oriented programming, I mean, really it's just a specific class that you use that will define a infrastructure resource. So whether it's a task definition in ECS or a load balancer, anything, you know, that is a construct. And CloudFormation stacks themselves are it's a separate class, but that's derived from construct. So yeah, it's very much they really leverage the object-oriented nature of it, which is really nice. That's something that CloudFormation you really had a lot of trouble with. I mean, JSON and YAML, it's very declarative. So like right from the beginning, they wanted something that, you know, you would write your template and say, this is what I want my infrastructure to look like. This is everything in this template is exactly what it should be. And I mean, over time, they would add things like intrinsic functions, which added a little bit more something you would see in like a regular programming language, conditionals, but still no for loops, right? And just having something simple like a for loop it makes things so much easier. I mean, especially when you're talking about having some resources that would be applicable in one environment, but not in another environment. So like, you know, dev versus prod, right? If you wanted to change some of the configuration too, you know, based on what environment you're on, like for a dev environment, let's say if you have RDS instances, you might not want to have a whole bunch of like really beefy RDS instances with that are multi-AZ, because that can kind of run the bill, and that might not be applicable for something like dev. But you want to absolutely have something like that in prod. You know, that it makes it a lot easier to have those environment specific changes too. Yeah.
Yeah, in that vein, it's nice because with CDK, it'll let you create instances of classes rather than just having to redefine the entire thing per environment.
Right. Yes, absolutely.
I think another benefit of CDK that I appreciate is while it takes away having to manage raw CloudFormation, you still have the option to use it or define the CloudFormation nodes. And in that same vein, when you deploy it, you get to look at directly what CloudFormation it's trying to push out.
Right. Yeah. So, and I don't know if we covered this. I think we might have covered this a little bit in the first few minutes, but really underneath the hood, what it's doing is, even though you're writing the code in Python or .NET or what have you, when you run the CDK synth command, it's actually compiling that down into CloudFormation templates for you. And so just like you're saying, Phil, I mean, you can actually see the templates, the resulting templates, but also, I mean, even through the scope and the scope tree, which we might get into the nitty gritty of this later, but you can really see like all of the different resources that you're creating as they would appear in CloudFormation. And actually on that topic too, what's really nice is you have different levels of constructs, right? So like you have very basic constructs that are pretty much one-to-one with CloudFormation resources. So that exact same resources with the attributes you'd see in a CloudFormation template, I mean, you can create an L1 or level 1 construct it's a pretty much a one-to-one mapping, but you can add other constructs like L2 or L3 even that are derive from that make it even easier. So for example, like, you know, there's a CloudFormation, or I'm sorry, not a CloudFormation, a CDK pattern for a load balanced Fargate service. right? An application load balanced Fargate service. So if you wanted to instantiate all of that in CloudFormation, or even as just like L1 constructs, you need to create the task definition. You'd want to create the ECS service. You need to create the load balancer, and then all the target groups, and make sure that they're all hooked up together. But you can actually encapsulate all of that in a single class. And then if you have multiple services that have that same pattern, you just create new instantiations of that class, and it becomes extremely easy to reuse over and over.
Yeah. I actually have a recent example with this with one of our clients. We were looking at making some hefty changes in how their applications connect to their database. And it was really nice that I was able to just create a new environment just by standing a new instance of the application.
Right. Yeah, absolutely. So yeah, and all these are like really, really good things about it. But there are some drawbacks, like we mentioned before, and it's good to be aware of them just so that you don't fall into any pitfalls. There's one thing that we ran into, I think, really early on when we were looking at standardizing on CDK as a company. With RedBrain, we always just default to using CloudFormation if our clients didn't have any specific preferences. But really, when CDK came out and started maturing a little bit, we took a hard look and decided to standardize on it after getting all of the after seeing all the benefits that we could reap from it. But we ran into some pitfalls, and one of those was getting it production ready. And I think the biggest one, at least for me, was environment specific context. So with CDK, there's something called the CDK context, which you can edit through the CLI tool, or you can just open up the file, the JSON file directly. But it basically allows you to have environment variables that you set that can sometimes change. But for example, let's say you had a whole bunch of lambdas, right, that you've got set up in your CDK code, and some of them you need to have them set some certain environment variables for them to function properly. You can actually set these in the CDK, and then the Lambda can pull these from the CDK context. However, if the variables that you have set in the CDK context are different from environment to environment, which oftentimes they are, it can be a little bit tricky to actually get that handled properly. I remember there's a lot of work that we needed to do to get that to a point where it could handle environment specific context as well as just environment specific stacks. Now, there is an environment construct that specifies the AWS region and account number, but if those are the same for both your dev and staging or pre-prod and prod, then you still need additional work to make sure that you have the right context for the right environment specific stacks. And just real quick, one of the things that I ended up doing to fix that, just as like a stopgap, without going into like the really in-depth fixes, was I actually had a stack that inherited from the base stack provided by CDK, like the stack class, that would actually have a private function that, based on the environment name that you give it, it'll switch what context you're using. So like you can have a single CDK context.json that has a bunch of nested dictionaries, like JSON objects, and the key would pertain to the environment. So dev, pre-prod, prod, and then within that dictionary, you'd have, a whole bunch of your other environment specific stuff. But yeah, at least as a stopgap that worked for a while. But yeah, there were some other things we had to do, I think, to really make use of that. Did you have any particular flaws or pitfalls that you ran into, Phil? Like when working
Yeah,
with CDK?
I've got a somewhat big one that I run into sometimes. CDK itself is great, and I love the option of all the different languages we have available to use. That said, if you're not using TypeScript, there is a specific pitfall you could run into, and that's troubleshooting JSII errors.
Oh, that's a great point.
The native language of CDK is TypeScript. So if you write it in anything else, it has a interpreter in the backend that effectively converts everything. And some things just don't work from one language to the other, and you just get thrown this pitfall of errors that you then just get stuck troubleshooting.
Right.
It's not always necessarily an issue with your code. Sometimes it might just be an issue of how you implemented it, whereas that's just not something that can be feasibly translated.
Right, yeah. And I think that's the reason why we ended up standardizing on TypeScript, because that is the original language it was written in. And that also helps with debugging too, because it's it's more obvious as to like
It,
what the problem actually is, right?
it's more obvious, and it removes the translation error that we would then have to work through.
Right, absolutely. Um, how do you like we talked a lot about how the CDK compares with CloudFormation itself, because it's using CloudFormation under the hood. Um, did you have like what how would you compare it to some other tools for infrastructure as code?
Um, in that case, my primary experience outside of CDK would be with like Terraform. Terraform has a lot of benefits in being that it's multi-platform, whereas CDK is specifically built for AWS. And Terraform tries to go about being object-oriented to a degree, but it lacks all the operator options that you would get from any other programming language.
Right. Yeah. And that's something that I've used Terraform quite a bit as well, and even a little Ansible in the past. But yeah, like it's funny because with Terraform, they tried to provide a little bit more of those kinds of options than CloudFormation did. I mean, with CloudFormation, they're like, no loops, we're not doing loops. But with Terraform, you do have some limited ability to do that, with using count for your resources that you're creating, or for each now is the thing in the
Yeah, you've got count, you've got a basic for loop where you could run through a map. You've got your if condition statements. Like there's a couple of options, and they're better than just raw cloud formation. I think one of the big hangups with Terraform though is in how it typically handles its states and deploys compared to CDK.
Right. Yeah, like could you go a little bit more in depth into that?
Yeah, of course. CDK, when you deploy, it will create the CloudFormation template and start to obviously try to make your changes. If everything's great, it'll upload the new template, and that's the end of it. If there's an issue and something were to fail, like let's say I'm trying to push a change to my ECS service and it causes a redeploy on the ECS. If that deploy were to fail, CDK would still keep the old instance up and there would be no issue. It would just basically spit back an error telling me, hey, there was a problem, but don't worry, your stuff is still running. With Terraform, they typically do a destroy, then a deploy. But if things fail out, they don't restore either.
Right. Yeah. And I think that really comes down to the way that deployments are handled gracefully or ungracefully, like between Terraform and CloudFormation as well. Because I mean, in my experience, CloudFormation's better at things like rollbacks, which Terraform does not have any native support for.
I mean, I think the big issue in that vein is that Terraform is typically all done through the API rather than some form of CloudFormation.
Mm-hmm.
Everything you write does a bunch of API calls, which is great if you want to use a service like Cloud9 to see what, not Cloud9, CloudTrail to see like what happens. But in that same vein, there's no form of state that AWS itself is aware of. So it has no idea how to revert or correct if there's an issue. And then in that vein, Terraform has its own form of state. You can store it locally, or you can store it in like S3 or other services, so that multiple people working on it have access to the same state file. And if there's an issue, you sometimes have to go in and manipulate that file.
Right. Yeah, and that could be really dangerous. I mean, with Terraform, that's like they strongly discourage you to mess with the state directly, because I mean, you could really break stuff. Yeah.
Yeah, but unfortunately, pending how whatever you were trying to deploy failed, you don't always get a choice.
Right. Yeah. Yeah. You get into these weird situations where like you've passed the point of no return and you have to like go through and fix things and get the rest of the way there just to get the environment into a decent state to finish the deployment. Yeah, it can be really, really messy. But so like, let's say, going back to CDK, like if you had a choice, like let's say that the translation part between languages isn't really an issue. Like, what would be your choice, your programming language of choice for CDK, just like as a default?
My default choice would probably be Python. Just like how CDK takes care of a lot of overhead of CloudFormation for you, Python will take care of a lot of overhead in terms of the programming language and everything it's doing under the hood. I like the customizability something like TypeScript gives you, such as like interfaces and stuff like that, but that's not always needed. Sometimes going the simpler, more readable route is going to be better in a collaborative effort than having to do a code crawl every time you want to add a stack, update a stack, or anything like that. Because you'd have to go through all their additional implementations and definitions to get everything running as you'd want.
Yeah, absolutely. Yeah, I also would choose Python as well. Just that's the language I'm the most I have the most comfort with now, even though I mean I've dabbled and worked a lot in the other languages too. But that's kind of the main point I was getting across, is like it does give you that flexibility to choose what you're comfortable with and actually like spin up resources, do infrastructure as code with the programming languages of your choice within the the scope of the what they provide. Even though some choices can lead to a little bit more heartache than others, but like I think yeah, the safest choice is TypeScript, but yeah, I mean the other ones work just as well in my experience, especially Python. I like that one too. Um,
Yep, it's easy, it's convenient, guaranteed to work across every system, and it moves with you.
yeah, absolutely. Um, Cool. All right. Well, we're getting close to time here. I just want to leave a little bit of room for some closing thoughts. I mean, what do you think? Like overall, like thumbs up, thumbs down. How would you rank this among other infrastructure as code tool choices?
Having a predefined language that's widely known and universal, I would probably rank this near the top. Um, Terraform, I would probably throw in second, but this also just kind of ends where my experience with these types of systems come into play.
Right.
The friendliest thing I think the greatest benefit I had is coming into CDK. I had all of my prior Python experience to rely on, and it saved half the battle in trying to learn how to use CDK.
Excellent.
Jumping into Terraform, I had to learn the specific language they use.
Right. Yeah. Which is a unique to HashiCorp. Right. Yeah. Excellent points. And I agree with you there. I mean, for me too, two thumbs up. I wholeheartedly recommend CDK, especially with all of the support that's been thrown behind it from AWS. It's continuing to evolve and change and get better and better. And it just makes things so much easier. So yeah, wholeheartedly recommend that. Definitely at the top for me.
Yep. Um, that said, going forward, if anyone's going to check out CDK, start with V2. V1's in maintenance. They're trying to deprecate it. They're not going to add anything new to it. Do V2, get all your options, and go from there.
Awesome. Excellent. Great. Okay. Well, I guess with that, we can pretty much bring this to a close. But yeah, thanks again, Phil, for having this discussion with me about CDK. And yeah, thanks everybody for joining and listening. And Yeah, we will see you next week.
Sounds good. Thank you, Jason.
Thanks, everybody.
Bye-bye.
Thank you.